to get started. We're going to have 3 presentations, 2 from Congruence Engine, 1 from Sloane Lab. So we have Nayomi Kasthuriarachchi from Congruence Engine. She's a research fellow in Digital Humanities in the Science Museum Group. And she's going to be presenting the first presentation, History-Graph, followed by Marco Humbel from the Sloane Lab. He is a research fellow in participatory design and collections as data at UCL London. He's going to be talking about collections as data infrastructures. And finally, Natasha Kitcher from Congruence Engine as well. She is a research fellow in digital history of communications at the Science Museum Group. And she's going to be talking about how researcher notes from archival can be used for community-generated data. And well, it should be very, very fun. So at the end, we're going to have the Q&A space. So please stay after the Q&A or feel free to ask us any questions. So Nayomi, feel free to unmute yourself and begin your presentation.
Now, just going to share my screen. Okay. Going to begin in classic Zoom fashion. Can you see that?
Perfect, all good.
Okay, we're good to go. So thank you, Javier, for that introduction, and thank you to everyone who's joined online today. I work as a data scientist on the Congruence Engine project. I am fortunate enough to work with many knowledgeable historians, but I am not actually a historian myself. That is to say, if you ask me any deep and probing historical questions, you'll probably be very disappointed by my answers. Day to day, I research methods for connecting data sources on Britain's industrial heritage in the energy, communications, and textile sectors. And the talk that I'm going to give you over the next 20 minutes is about my main area of work at the moment, which is part of the textile strand of our project and involves using graphs to connect data about or associated with the textile mills of Bradford and surrounding areas in the 19th and early part of the 20th century. So before jumping in, I just want to give you a very brief outline of how I've structured this talk, and that's by answering a series of questions. First, we'll touch on 2 foundations of the Congruence Engine project that apply to this work or investigation, to use Congruence Engine parlance. Next, I will talk about why we're focusing on Bradford and why we've adopted a graph-based approach here. And finally, I'll use 2 case studies to demonstrate how we're building these graphs before concluding by talking about what we hope to do next with this investigation. So the first foundation I want to discuss is linkages. Congruence Engine was set up to investigate ways of creating linkages between previously unconnected data sources as a way of facilitating and broadening historical inquiry. We're achieving this not by creating a giant linked data store, but through probing a range of different ways of making connections between the data we're interested in. For the work that I'm discussing today, what this means is making connections between, for example, data on mill sites, their architecture, who owned these mills, who designed them, who worked in them, what machinery they used, which products they produced. I think you get the picture. Making connections allows all of us working on this project and anyone with an interest in this area to tell better, richer stories about this particular area of Britain's textile heritage. The second foundational component I want to discuss is the concept of the social machine, because it features in the way that all Congruence Engine investigations work. Like this illustration by Keith Robinson of a machine that's supposedly for testing artificial teeth, a social machine requires input from both humans and mechanisms, and in our case, the mechanisms are digital. Unlike a Keith Robinson machine, none of our work is unnecessarily complicated and without practical use. But like a Heath Robinson contraption, a social machine needs both the human and the mechanistic elements in order to work. So how do we build graphs as a social machine process? Well, we start with human interest and the need for human inquiry, which is reflected in data sources that have been unearthed, created, cleaned, and collated by humans with or without digital methods. These sources are then fed through one or more digital processes to craft networks. At each stage of the process, there is human input in the designing of the data ingestion, the process of tweaking and reviewing, and the curation of the output. What we're doing here is definitely not looking to jettison critical thought by accepting the resulting networks at face value as a representation of what actually happened in the past. And as I will show you in a little while, the historian is definitely not in any danger of being replaced by machine-derived networks. And it remains critical that we interrogate the networks that we extract thoroughly. Personally, I see digital tools in my work as a torch that helps us to shine light on information that's too complex to process without the intervention of machines. And I see the results that we get from digital methods as prompts to drive further human-led historical inquiry. Moving on, why Bradford? Well, setting up a social machine, and in particular to Bradford, West Yorkshire, was always one of Congruence Engine's stated objectives in the final year of the project. Added to this is the fact that Bradford and its surrounding areas are hugely important in British textiles history. Bradford, driven by its access to raw materials, waterways, fuel, building materials, and human resource, reigned the textiles producing capital in the 19th century up until the mid-20th century. The largest silk factory in the world at one point, Lister Mills, was in the district of Bradford, but the thing that Bradford developed a real preeminence for was the production of worsted cloth, a type of wool textile made by recombing and spinning longer wool fibres. Bradford's worsted output was so prolific that it was given the moniker Worstedopolis by the Bradford historian William Cudworth. As we can see from this illustration of Bradford from around 1870 called Spinkwell Quarry, all of this industrial activity required a lot of industrial buildings, so factories and mills. In terms of textiles manufacturing, it has been estimated that there were once 350 mills in Bradford and its surrounding areas, including Lister Mill and Salts Mill, a vast state-of-the-art textiles mill complex opened in 1853, situated next to the purpose-built Saltaire model village, built by Salts Mill owner Titus Salt to provide his workers and their families with houses of improved quality. And now on to the final why. Why graphs? Why model any of this data on Bradford's textile industry as a graph? Well, what we have here is relationship data, for want of a better description. Relationships between mill sites, owners, workers, occupations, machinery, processes, etc. Graphs, where things or entities are represented as nodes connected by lines or edges showing the relationships between the things, are an ideal way of modeling these relationships. And as I'll demonstrate in a bit, in a graph, a relationship is explicitly stipulated by the model and doesn't have to be inferred by looking up different sections from different data sources and trying to join them together. I'll also try to show that graph modeling is flexible. So if a new data source needs to be integrated, this can be done without having to refactor the whole data model. And finally, once we have a graph, we can apply all kinds of interesting network science to it, like identifying groupings or longest or shortest paths of linkage in a reasonably straightforward way. So that's enough of the theory. Let's look at some graphs. To touch very briefly on the tools that we're using, the logos on the left represent the tools that we've used to date, but I'm sure we'll add more before the end of the investigation. We're using the graph database Neo4j in order to store the data and to construct the graphs. There are other methods of constructing graphs, and there are indeed other graph databases, but Neo4j is very widely used, it's well supported, it's robust, it has all manner of libraries for graph construction and analysis, and importantly, several free versions that can be used on a development project like ours. We're using Python for data cleaning, ingestion into Neo4j, running the graph algorithms, and for analysing results that we pull back from the graph. And recently, when dealing with unstructured text, we've used generative AI to help with graph construction. Specifically, we've used the LangChain framework's wrapper to combine Neo4j with OpenAI's GPT large language models. And I'll show you a bit more of this work when we look at the case studies. I'm going to make a fleeting acknowledgement here of our data sources by virtue of this word cloud. There are so many of these, and I've only listed the main ones here. What I'm now going to do is talk about constructing graphs from two of these sources of data, census data and free-form text from an essay. Both of these data sources focus on the human components of the textile industry. And the reason for this is because this is an investigation in process. And this is the data that we have processed for the moment. Starting with CSV data, the data in the two tables here is pretty much, it's the dream scenario. It's been carefully curated and cleaned by someone with an in-depth knowledge of the source. The fields are well defined and the data is ready to ingest. I really don't expect that we'll get too much that's quite as good as this. The two tables that we see here are a small extract from Saltaire's census records. We have 22,000 entries in total relating to about 2,000 families who resided in Saltaire over a 50-year period between 1861 and 1911, so 6 censuses in total. And I've chosen here to show you the records belonging to one family, the Wardmans. As far as I'm aware, there's nothing particularly remarkable about the Wardmans. They just had a small enough data set of records to allow me to graph them for this presentation. The table in the foreground with the blue header lists the census year, the names of the Wardman family recorded in each census, their respective addresses, years of birth, the towns in which they were born, and their occupation at the point of each census. Each person has also been given a unique ID, which we can use as an identifier. The table with the orange header in the background is a table of relationships. And to simplify things here, I've limited the relationships to just those to the patriarch and matriarch of the family, George and Anne Wardman, who you see here highlighted by the orange box in the foreground table. So what this means is that I've ignored all the sibling relationships here. The first step to getting data into a graph database is to design a schema to specify how the data model will look. There are potentially lots of ways to draw schemata for the same data. This is just one representation I've gone for here. You'll see that most fields from the blue table on the previous slide have been translated to graph nodes here, represented as circles with different colours. The exception to this is the birth year field, which I've assigned as a property on the person node alongside ID, forename, surname, and full name. Again, this is just a modelling decision that I've made. It doesn't have to be modelled this way. Relationships are entities represented by arrows. The direction of an arrow shows the direction of a relationship. Here, I am using related to as a placeholder in the schema to represent all interperson relationships. The naming conventions that you see here are standard for this type of graph model. Nodes are in title case and relationships are in uppercase in past tense with words represented by underscores. Occupations have been linked to census year in this model just by the occupation listed in relationship, which will allow us to track changes in occupation over time. You'll also see that I've included a street node here and tagged that to the address node. The reason I've done this is to show how we might then query this model to find out if, for example, there were clusters of people with the same or similar occupations living on the same street or group of streets. I talked earlier about graphs being flexible. So if we imagine now that I have obtained data from an occupations ontology, linking jobs to particular machinery or types of places within a mill, and I hope you can see the scope for extending out this model via the occupation node at the bottom in order to allow this additional data to be grafted on. Let's see what the Wardmans look like as a graph. So Neo4j uses a force-directed layout as its default, so I've had to manipulate this graph a bit to get it looking like this. There are so many ways, so many things that can be done to improve the visual output of network diagrams, and I'll try to touch on those at the end. I'm not sure how clear this is, but you can see here the family represented as light brown nodes in the centre of the graph. George and Anne are at the top row with their 9 children arranged left to right in birth order, running from 1861 to 1879. If we remember, year of birth is stored as a property on the person node, so we can't see it explicitly here. Eleanor Wardman, who appears at the far right, is not a child of George and Anne, but was in fact George's niece. And we also see here that there's a grandson, Percy Wardman. As we're only focusing on the relationships to George and Anne, I haven't modelled his parentage in this graph. We can see from the census nodes at the top that the Wardmans first appear in the Saltaire census of 1881. Members of the family then remain in Saltaire for at least the next 20 years. At the left and right of the graph, you see the blue nodes denoting town of birth. And what we see from this is that prior to settling in Saltaire, the Wardmans appear to have led quite a peripatetic existence, with the Wardmans' 9 children being born in 7 different towns or villages. We see from the address nodes that George and Anne's family occupied 3 addresses in Saltaire. And if we now interrogate this a bit closer, we see that the family initially lived at 11 George Street, but by 1891, it appears that Anne may have sadly died, leaving George living with 3 of his children and a grandson at 5 Catherine Street, which is the middle picture. But by 1901, on the far right, the only remaining member of the George and Anne branch of the family remaining in Saltaire is Arthur Wardman, who had moved to an address at 13 Mary Street. It's possible that George had died by 1901 and that Mary and Ellen, with whom he'd been living 10 years prior, had married and changed their names. Expanding this data to search the full record set may reveal some answers to this, as well as potentially connecting registers of births, deaths, and marriages. Moving on to look at occupations, we can see changes in occupation over time. We see from the picture on the left-hand side that Ellen Wardman was initially employed as a worsted spinner in 1891, but by 1881, but by 1891 had changed trade and was recorded as a silk spreader. Arthur Wardman, who's represented in the picture on the right, had been at school in 1881 and was listed as a scholar, but had become a plush finisher by 1891 before changing professions to become a mason labourer by 1901. It's possible that you're looking at this and thinking, so what? All of this could be inferred by looking at the 2 tables at the start of this case study. This is true, but now imagine expanding the record set to 22,000 records. Making connections in the data would no longer be possible by simple observation. Personally, I think that this kind of network analysis and visualization makes for a really accessible tool to use in engaging interested parties via the social machine about what more could be done. One thought that we've had is to combine these records with a set of oral histories of Bradford that we are currently transcribing using a digital speech-to-text pipeline. Using graph methods, we could then connect mentions of places in Saltaire in the transcription to the addresses of individuals via the census records. So if the previous source data was the dream, now we're going to look at, well, it's not the nightmare, but it's a more common presentation and one that's more challenging to process. A lot of the data that we look at will be in the form of free-form text from essays, books, and online sources. How do we begin to identify entities and relationships from free-form data? We're going to look at one particular example, the layout of which I've tried to illustrate in the image in the box with the orange border in the foreground. This is a 12,000-word essay on the history of 4 textile mills, written by an academic historian who's also a co-I on the textile strand. I've blurred this image a bit just because I'm not sure how much of it I'm allowed to show, but the text covers mill sites, mill owners, workers and their families, mill rights, references to textiles, business relationships, significant dates, and lots of other details. We've used an experimental process to extract entities and relationships from this text by combining Neo4j with, and I'm going to mention the evil word, generative AI, and large language models, or LLMs. Quickly touching on the pipeline that we use to do this, we start at step 1 with our essay in a Word document. This then gets loaded into LangChain and split into bite-sized pieces for the LLM, using LangChain's document loading and text splitting modules in step 2. We feed the LLM fairly large chunks of about 2,000 characters in order to preserve as much context as possible. LangChain already knows what the structure of Neo4j relationships and nodes should look like, and in step 3, we provide our LLM, in this case we're using a version of ChatGPT 3.5, with prompts to tell it how to label the nodes and relationships that it finds. We've kept the prompts quite general initially and haven't tailored them to our dataset, just to see what the LLM returns when left to its own devices. The LangChain wrapper for Neo4j allows the graph database to be integrated with the LLM, and we use Python to drive all of this to end up in step 4, with the LLM outputting a graph to Neo4j. So let's see how AI represented the life of Samuel Gregg, who is referred to multiple times in the text. Those of you who know Samuel Gregg may wonder why I'm discussing an industrialist associated with the Manchester cotton trade in a talk about Bradford. The reason for this is that we're still refining this process, and the full graph, which you can see at the bottom left here, contains a large number of unconnected nodes, and I've yet to find out why. Samuel Gregg features in one of the main connected sections, so we'll be able to say lots of interesting things about how the LLM identified relationships related to him. Once we've refined the process to correct as much as possible about the way the LLM extracts Greg and his relationships from the text, we can apply this improved process to focus specifically on Bradford entities. We'll use 4 text extracts from the essay in turn to gauge how well the LLM did. The first extract concerns Greg and his wife, and we see that they are correctly identified as orange-coloured person nodes. The spousal relationship is correct, although not bidirectional. It ignores the reference to the chapel that was the couple's meeting place. You can't see here, but Hannah's birth and death dates are correct and attached as properties on the node, because that's what we've told the LLM to do with dates for the moment. Concerning Hannah's parents, we see that the correct individuals and correct relationship have been identified, but that the direction of the relationship is incorrect. The 2 business relationships mentioned here are modelled correctly, and what is interesting is that the original text does not mention the relationship of business partner specifically. So this relationship is something that the LLM has deduced for itself. And finally, we see the village of Eam is correctly identified as a location, but the fact that it was a mill and not Greg himself supplying the shop at this location has been ignored. Similarly, Rathbone is correctly identified as a supplier, but to Samuel Gregg and not to his mill. So to wrap up, where next with this investigation? I'm going to focus on the immediate priorities instead of my wish list due to time. Firstly, we need to build out the Saltaire census analysis to reflect the 22,000 records. The main work here is in working with the code to correctly specify the person-to-person relationships. We also need to get the humans back in the loop to check and consolidate the entire list of LLM-generated entities and relationships against the human-produced ground truth of the essay, which is people going through the essay and picking out entities and relationships manually. We'll then do some prompt engineering work to specify a schema to the LLM of the nodes and relationships we want extracted, and this should improve the accuracy. We can then try to generalize the schema definition process for other data sources. Another priority is to improve visualizations, because we want to encourage historical inquiry by allowing people to engage with the graph easily. There are lots of tools that produce amazing network visualizations, although ideally we'll be able to develop a bespoke interactive interface for our graph. I have to add, this won't be my job. This will be more digital techniques and impressive humans in the loop. As a closing point, it's really a privilege for me as a data scientist in digital humanities to use these inventive cutting-edge techniques for data linkage. And I really hope the work won't end with the end of this project, and that we'll be able to build out follow-on projects to hone techniques, improve interfaces, and connect more source data. Thank you very much.
Thank you, Naomi. Yeah, very, very interesting. So please post some questions. Well, I already have lots of questions, but please use the Q&A to post any questions. So yeah, thank you, Naomi. Next, we have Marco from Sloane Lab. As you can see, he's already sharing. So yeah, welcome, Marco, and go ahead.
Great. Thank you, Javier and Naomi. So you're able to see my screen, is this correct?
Yes, perfect. Thank you.
Okay, perfect. Yeah, good afternoon. My name is Marco Humbel, and I work as a postdoctoral research fellow at the Sloane Lab project, focusing on participatory research methods and collections as data. In this presentation, I won't speak about the Sloane Lab itself, actually. Rather, I will zoom out and report on our research that we facilitated that looked at memory institutions' perspectives and challenges when it comes to participating in digital infrastructure projects. Oops. So through mass digitalization efforts in the last 20 to 30 years, and technologies such as optical character recognition, digital collections became amendable in ways which are unique to data, such as text mining, network analysis, and machine learning applications. Some scholars, such as Thomas Padilla, does speak about a turn towards collections as data. There are high expectations of what these data-fied collections will enable. Researchers in the arts and humanities seek to respond to new and old questions through the means of data. The creative sector leverage collections data for artistic interventions. Commercial firms create new business models, and also governments seek to boost the digital economy through collections data. So for this reason, there's at the moment quite a huge investment in national and international programs for creating these kind of large-scale infrastructures for collection data dissemination and unification. The Australian Research Data Commons, for instance, invested in the Trove aggregation platform to improve data-driven access to collections for humanities and social science researchers. In Europe, we not only have the TaNC program, but also, for instance, the European Commission's investments to develop the so-called Common European Data Space for Cultural Heritage. The Data Space program for cultural heritage is led by the Europeana Foundation to create links and facilitate access to this collections data via the existing aggregation platforms. Then in Germany, we have also, for instance, although more from a research data science perspective, but still goes into the collections data perspectives. We have projects like the NFDI for memory. So the Sloane Lab's main aim is to facilitate digital access to the dispersed and historical and present-day information that describes the collection accumulated by Hans Sloane. For this reason, our project serves as a microcosm or case study for virtually unifying collections on a UK-wide basis. For this reason, we were interested in to learn more about the accelerations and constraints of libraries, museums, and archives in their role as collection data providers for digital infrastructures beyond the immediate partner institutions we have. So the questions we were interested in included: what are collecting and heritage organizations' experiences of participating in digital infrastructure projects? Which factors enable and impede them in unifying siloed collections? And also, what kind of risks and opportunities do collecting and heritage organizations perceive in large-scale infrastructures investments, such as the TaNC program? So from January to May 2022, we conducted an extensive literature review on digital collections unification at scale. As among others, highlighted by Carlotta Paltrineri's TaNC benchmarking review, to date, the unification of collection data at scale is typically facilitated through data aggregation platforms of international or national or domain-specific scope, such as Japan Search, Cultura Italia, Cross Europeana, or the Global Biodiversity Information Facility, short GBIF. The emphasis of the research that addresses how collections can be unified at scale tends to focus primarily mostly on technical outputs and finding ideal copyright licensing frameworks for data exchange, as also mirrored in the TaNC Foundation projects or in their outputs. However, given the fundamental role heritage organizations are ought to have in these digital infrastructure projects as agents for curating these collections and bringing them into digital formats in the first place, surprisingly few qualitative research is concerned with their perspectives and capabilities to do so. Instead, heritage organizations' experiences tends to be dispersed across an abundance of case study reports and grey literature. As a response to these observations, we identified semi-structured interviews to be the most suitable data collection method to move forward to explore heritage organizations' experiences, needs, and aspirations regarding digital infrastructure projects. In June and July 2022, we facilitated a series of consultations with curators, archivists, librarians, and IT specialists across 10 heritage organizations and aggregators. Our sample included organizations such as university collections, national organizations, and community archives. We developed a questionnaire which, while not exclusively, aimed to initiate discussions on non-technical issues for virtual collection unification. And for the main part of this presentation, I wish to discuss some of the findings of these conversations. Broadly speaking, interviewees acknowledged positive experiences of digital infrastructure projects. Merit and opportunities of these infrastructures were expressed in respect of data enrichment, collection exploration, display, and of course, making collections available to wider audiences. Existing aggregators are also important platforms for especially small institutions to make their collections available in the first place if they don't have their own online cataloging system. The potential of analyzing collections at scale through their unification was acknowledged too, but it's mostly seen as an interest confined to specialized audiences, such as digital humanities researchers. While there could be a potential for institutions themselves to explore their own histories and collections through virtual unification, this was an avenue not of core interest of the organizations we interviewed. Notwithstanding a broadly positive attitude to aggregators, interviewees often seem to question whether collecting and heritage organizations' experiences such infrastructures as novel, scarce, or technologically cutting edge. In fact, to date, collecting and heritage organizations have been able to choose from an abundance of aggregators or other solutions to share collections data outside of their own catalogs. The UK Archives Hub emerged in the late 1990s, literally out of the ambition to create a national archives gateway, for instance. Another example is the Europeana UK aggregator Culture Grid, which operated until 2015, before it closed down for new contributors. Strong frustration across interviewees surfaced in respect to stalled infrastructure projects. However, it's important to say that there is also a number of successful examples of contemporary collection aggregation platforms running in the UK, such as the aforementioned UK Archives Hub and Art UK, of course. As interviewees questioned aggregators as the technological state-of-the-art approach, they expressed instead interest in decentralized approaches for collection unification. What such an approach could practically look like remains unclear, however. Linked open data approaches have not had a wide uptake in the sector, despite having had some presence over the last decade. As the TaNC Heritage Connection project already suggested, lightweight interfaces and toolboxes for collection data exploration could also offer ways forward, but they also require a certain level of technical expertise from the users. An example of how such lightweight interfaces for collection data exploration could look like are, for instance, the GLAM workbench by Tim Sherrod. The European Commission ambitions in respect to the common European data space for cultural heritage also lends itself to decentralized approaches for collection data unification. However, to date, there's also a lack of consensus for this concept of the data space for cultural heritage ought to be in practice if we look into literature. Despite advances of decentralized technologies such as linked data, there's to date not a robust framework for a coordinated approach for facilitating interlinking collections data in a decentralized manner. Interviewees perceive in large-scale infrastructure investments also risks for small collecting and heritage organizations. Strategies and policies surrounding aggregation infrastructures are, from the perspective of small institutions, which are, after all, the majority in the UK sector, structurally flawed. Competitive funding calls also risk by definition to reinforce the asymmetries in collection visibility between major heritage organizations and smaller institutions, which may not have the resources, skill sets, and networks required for participating in major funding schemes. Participation in aggregation infrastructures more broadly often takes place in an ad hoc manner and not as part of long-term strategies. Interviewees identified the absence of a sector-wide strategy and a competitive funding landscape as key drivers for the fragmented digital collections landscape. Linked to this issue is the tension that arises between innovation and sustainability. The limited capabilities of even relatively well-funded heritage organizations to disseminate collection data sits much at odds to the scope of current infrastructure investments, which tends to call for innovation rather than leveling up work and sustainability. Interviewees observed that there's commonly an underestimation of the complexity entailed in building large-scale infrastructure projects, and that the capabilities of main institutions to deliver data is often limited. Responses from my interviewee consultation suggest that also legacy systems with limited capacity for data management and export is a phenomenon present across the sector, or not something that, for instance, limited to small institutions only. A final theme that surfaced in our conversations is that divergent disciplinary traditions between libraries, archives, and museums tends to be obscured when we speak about infrastructures which aim to cater for all types of collecting and heritage organizations. The unification of collections at scale is not simply a matter of finding the appropriate technical tool. It is shaped and hampered by the inherited, first and foremost, Western norms, practices, and cultures of information management, which developed over the last 200 years. Museum collections description emerged, for instance, out of the need to register and manage objects internally, not for external information retrieval. So information management via cataloging standards and vocabularies gained in the museum sector for this reason a less prominent role than in libraries, for instance. Consequently, the linking of museum collections internally or externally with other collections is hampered. Larger organizations, for example, commonly have also specialized departments, bespoke collection management systems for different domains, such as humanities and natural sciences collections, or different collection types like library, archive, and museum collections. Noteworthy is that the difference in collection types and their descriptions also play out in respect of heritage organizations' ability to comply with copyright licensing standards, as copyright clearance requires the identification of a creator of a piece of work. Depending on the cataloging practice, for example, in case of archival collections, the identification of authorship may not be a central concern, because archives tend not to describe on an item level, but focus on contextualizing the relationships between administrative and individuals' activities of record creation. So to conclude, heritage organizations' capacity to participate in digital infrastructures is dependent on a complex interplay of resource allocation across the sector and within organizations, divergent traditions of collection descriptions, and disciplinary histories and aims. To move forward, we suggest the following. First, sustainable investment and leveling up work across the sector to deliver collections data from different organization types. And we wish to highlight in particular the important role of smaller organizations to diversify the digital canon. Second, more studies on the impact and opportunities of unified collections data for heritage organizations themselves, rather than the research domain of the humanities only. Third, investments in existing infrastructures for collection data dissemination and unification instead of creating new platforms. This may also include bringing existing systems together. And fourth, establishing networks where relevant actors can communicate their experiences and needs in an ongoing way and influence policy. I wish to thank my colleagues who contributed in one way or another to the facilitation of this research. For instance, by developing the interview questionnaire or writing up the journal article, which is at the moment on the review, and we hope to be able to announce the publication very soon. So thank you very much to Nina Perlman, Andreas Vlachidis, Andrew Flynn, JD Hill, Daniele Metilli, Julian Nyhan, and of course all people and interviewees who participated in our interview consultations, without whom this research would not have been possible. Thank you very much for your attention, and of course I will be happy to respond to questions you have later in the Q&A. But I would now hand over to my colleague Natasha.
All right, thank you, Marco. So Natasha, are you ready? Natasha Kitcher from Congruence Engine.
Thank you. Sorry, I lost the unmute button. So that would have been a very long presentation in silence. There you go. So as has been alluded to, I am a research fellow focused on communication in Congruence Engine's project. I'm a historian, really. I have experience in the archive and the museum sector. And so I'm quite interested in the potential of these digital techniques to help a range of people interested in the past. An investigation that I have been running for Congruence Engine has been looking at how we might use personal researcher notes to create archival descriptions. This might be a way that we could enhance catalogues without relying on archivists alone to do the job, and it would use work that researchers are already producing through their own work. When thinking towards linkage, which is our goal, you cannot connect files that don't have any metadata, and so having automated methods to create descriptions would enable more information for more catalogues to be linked together. The big idea behind this smaller trial, which I will talk through shortly, is that we might find a way in the future to host researchers' notes and systematically transform them into catalogue descriptions for archives. This is not a totally new idea. Writers in the field have also suggested we could share notes as a way to combat what that has been called the citation crisis. And others have commented that we might start to store photographs that are taken in archives during standard researcher trips. My own inspiration for this came from my experience working with BT archives during my PhD. So I studied an object called the electrophone, which you can see in use here. I researched it for the PhD, and then I took a placement with BT where I enhanced the electrophone records. This involved manually creating catalogue descriptions, which meant I went back to files I had already read and redid some of the notes. I found when I was doing this that the notes were often very similar to what I would have written anyway during my PhD work, and who I was and what interested me as a person was still reflected in my archival notes, even if I was looking to be more general and summative. Within the Congruence Engine project, this proposition fits well within the social machine idea, in that anyone could get involved in a national collection in the future if they wanted to. If this were to be a big collaborative space where anyone could share their notes, anyone would be able to opt into the system, and they would be able to give back to the archive that they already rely on. In a world where notes could be automatically generated into descriptions, it would free up archivists' time to focus on other projects, rather than spending quite so much time dealing with cataloguing backlogs. To quote my colleague, James Elder from BT Archives, while economic trends have always been the threat, things like this new technology allow us to do more. So as I said, this idea, it was approved for a small proof of concept trial, which the rest of this presentation will focus on. The goal of the concept trial was to work out if we could generate notes, gather notes and turn those into descriptions. So the target was to recruit some volunteers, collect their notes, and then trial a few different methods of turning these into the catalogue descriptions. I always then intended to hold a period of reflective discussion with both the archive team as well as the researchers about the descriptions that were produced. So a series of digitized files without catalogue descriptions from BT, called the post-33 files, were selected for this study. I relied on digitized files so that the volunteers wouldn't need to come into London to view them. And because it was going to be focused on telephone collections, I sent an email out to the telecommunication heritage group. I sent an email out at 9 AM on a Tuesday via their mailing list, and within a few hours had about 9 people involved, which was enough for this proof of concept. And they all came from various backgrounds. So while some were historians, some were just old workers of BT who were interested in helping out with the archive. I explained to each of them the goal of the project, the potential for their data to be used in various machine learning environments, and the very real possibility that these descriptions wouldn't work. So very key to the project was that they all would have liked to read the files anyway. And so they would like if it helped out, but they were interested in what they were doing anyway. Also, as part of that, they each got to select their own files from a long list. And although 9 people were recruited, some of them were interested in the exact same files. I allowed for a bit of overlap so we could see if different notes led to similar descriptions. So in the end, 14 files were selected. The final stage of recruitment was when I asked everyone how they would usually take notes for a project such as this. And this became a key part of the study because I wanted to create a note description pipeline that would enable as many different formats of notes as possible to be used in the future. I provided a note-taking template, which you can see the note-taking form on screen, for everyone to think about using. So this would break down notes into sections and ask for research questions to be defined. Part of this was because I was interested to see if we would need a uniform way to input notes in the future. And this was also to help those that were less familiar with researching. I didn't enforce the use of this template because I wanted to see the impact of different input styles on the output. So in the end, about half used this note-taking form, half sent me notes that they typed up into Word, and 1 sent me notes that he had written by hand, and you can see a small sample on the screen. Although it was only 1 person that sent me handwritten notes, this was a significant factor in my decision to use the tool which I used, which was ChatGPT. ChatGPT, as you may know, is pretty good at reading handwriting, and it can then immediately do something with the transcript that it creates. Thinking forward, if this were to be a much larger scale enterprise, I would expect many more researchers to be making their notes by hand already, and so we would want to be including that work in this sort of project. The researchers were given 1 month to read their selected files and take notes. I was deliberately vague and perhaps uncooperative when I was asked for help with the notes. So if they asked me, is this looking right? Would you like me to make notes on this section? I would say, it's up to you, do whatever you want, to try and create something that replicated the normal research experience as closely as possible. So then I began transforming these notes and seeing how we could generate some descriptions. As I've already mentioned, I was interested to see if we would need a consistent format for feeding to ChatGPT to create descriptions. I was also quite keen to see if we could create descriptions that were simply lists of contents and weren't too chatty, which ChatGPT is very good at being chatty. So I turned all of the notes I was given into lists of keywords using Keybert. A small sample is on screen. What Keybert would have been doing was summarizing every line of notes and looking to get around 5 keywords. But maybe if it was a title, which I'm pretty sure line 4 is the title, you get less keywords. So I would then feed these keywords to ChatGPT and ask it to describe the source that the note taker was reading using the list of keywords generated from their notes. The initial results of this experiment show that GPT often quoted from the list it was given, and it still wrote quite conversationally rather than the list style that I was looking for. So here is an example. It's summarizing a file entitled Telephone Kiosks Departure from Standard Colour. Fascinating stuff. As you can see, it has quoted 3 times from the list it was given, and it has used words that would never be in an archival description, such as possibly, notably, and suggesting. It very much sounds like it's been given something and asked to have a guess, which really wasn't the output I was looking for. So at this stage, once I had transformed all of the notes I was given, I tried giving GPT a more specific prompt where I asked for it not to do the things wrong that it had done the first time. So for example, do not ever quote from the list you've been given. This led to slightly better results, but I started to notice that GPT was always going to be quite chatty, and maybe therefore it didn't need to be fed a list of keywords. If we could avoid feeding it a list of keywords, this would also hopefully speed up the process of generating descriptions, especially handwritten ones, which needed to be transcribed before being fed to keyword anyway. So at this point is quite a labor-intensive process. So with the knowledge that I had of errors GPT commonly made when creating descriptions, I set up what is known as a MyGPT, which is a customizable version of ChatGPT. This is something that was launched in November last year by OpenAI. So MyGPT, it can be fed specific source information. So you can give it a brand new knowledge base. And it, for instance, it could be trained on your own historical data, and then it can be a chatbot that uses that data. But for my purposes, I didn't need to give it a new knowledge base. I just set it up with one really long, very specific prompt where I told it, like, never quote from the notes, always return a 250-word description, and always start the description with this blur is. So maybe this file is, this document is, this image is. So it always reads like an archival description. And the result is something that you can feed notes to, whether they're handwritten, whether from a note or whether they're a Word document, and then just type create a description and it will give you a description. This also meant that handwritten notes could be used as they were sent to me. It may have implications moving forward, it is worth flagging. So anyone who supplied their notes beyond this experiment would need to provide them with the caveat they were happy for their work to be fed directly without processing to a large language model. This may be a limiting factor. However, I would hazard a guess that people who are happy for their work to be used to generate descriptions would also be happy for their work to be processed via an LLM, as they're quite similar training ideas. So here is the final description of the same file. It's still not perfect. So I've highlighted some parts that I personally would tweak in red. I do, however, think it's an acceptable stage where it could be handed to archivists to tweak before uploading to a catalogue. So this would mean that a human is in the loop for the final stage of the process, but still a lot of archivist time has been saved. I have shown the finished results to some of the team at BT Archives, who I think see the promise in the descriptions that I've generated. One surprising comment from this work is that to them, this makes the case for more volunteer-led projects reading archival files. They said that they'd be more comfortable with getting researchers to write notes and then trusting GPT to write the descriptions than they would be if they asked the researchers themselves, because the tone of voice is much more consistent. It's also worth noting that for BT Archives, as it's part of BT, a corporate archive, it's already a prerequisite in any of their AI work that a human must be in the loop at the final stage of a pipeline. And so providing them with notes that have been generated using ChatGPT but need a little tweaking is completely in line with their existing AI policy. The fact these descriptions aren't perfect, but are instead good enough, is not a concern for BT. And I would hazard a guess that other archives in the future would also be interested in having their own say on the final descriptions before they're ingested into a catalogue. So aiming for imperfection seems acceptable. I have also sent the researchers that were involved in this project the outputs that relate to their notes, as well as a feedback form using Microsoft Forms to fill in. The goal of this form is to understand if they change their note-taking style, so we can see how closely we've replicated a normal research environment, understand if they think the descriptions are complete enough, are accurate enough, and are good enough for use in an archive, and ask how they would expect to see automatically generated descriptions in the archive. So would they expect to be credited? And also, do they now trust these descriptions more or less than when they started? Feedback is ongoing, but so far it is mixed. The majority is positive, but this isn't entirely the case. So one researcher has expressed frustration at the confident but meaningless language that GPT has used, while others have said it did a much better job than they were expecting. Almost everyone has said that the descriptions are good enough, but that they would tweak it if given a chance. I suspect this is more to do with the fact they're all invested in the source material rather than any lack of completeness in the descriptions that have been created. Generally, the researchers themselves are a lot more relaxed than I am about how they would encounter these descriptions in the future. So most of them think that simply tagging their descriptions as AI generated would be enough. But then me personally and one of the respondents think that we would need a clear sentence in the public facing side of the catalogue explaining how the notes were generated, with a link to a longer article explaining the entire process. My feeling is that this is the only way to do our due diligence in letting the audience know about the role individuals as well as the large language model played in creating the description. I think in the future, it's important to show that large language models were used in an archive, but let's do this in a way that celebrates the involvement of individual researchers and volunteers where we can. As a proof of concept study, this investigation has shown that there is real potential for researchers' notes to be used to generate archival descriptions. This would enable more archival metadata to be produced, hopefully increasing the chances of linkages being made. There's potential for other studies just like this one to be done, where they could enhance specific catalogues at a specific time. But my real interest is whether we could generally store researchers' notes, so the researcher themselves would be interested in contributing and upload their notes, and then we can start to enhance a range of archival sources as they are viewed and as they are worked on by people in the field. This work, it's worth saying, it's not without its ethical considerations, both from the large language model side, as well as from the researcher's perspective. I think it's strongly advisable that these descriptions be marked as AI generated in the future, and it's very reasonable to assume that not everyone would be comfortable sharing their notes. Often we talk about sharing historical data when we talk about the national collection, and to me, sharing your own historical notes seems potentially even more personal. But in sum, this investigation to me has shown promise, it has proven the concept, and it could be a way for researchers in the future to start giving back to archives that they currently rely on. Thank you.
Thank you, Natasha. Epic presentations, everybody. I have a question for the three speakers, and it's related to this unification of data. And potentially, so how do you envision, for example, this, I will call it messy data from the notes, which you're structuring them in a form, or in a way, not in a form, trying to structure them so they can be reused. But then I'm wondering, how does this then, or what are the challenges into applying a schema or a data model, like the ones that Nayomi is actually implementing, to actually make it still more useful and transform into a knowledge base for the AI machine as well? And as well, so Marco, how do you see these kind of new tools embed into this type of the challenge for unifying data? So open question for the three speakers.
I can hop in very quickly in a way that probably strongly implicates Nayomi, sorry. I think Nayomi's work, especially the second example she gave of Neo4j, is strongly relying on large language models, and so is my work, and it's using messy data. And I think large language models are very promising because they can deal with the language that we use anyway, and maybe they can turn it into smaller chunks of language where we can then extract keywords. Maybe they can turn it into graphical databases. I just think large language models are hugely promising at this time. And therefore the messy data is no longer as much of a concern, even as it may have been a year ago.
Yeah, I would agree with Tasha on that. LLMs do deliver a lot of promise, although as someone recently described them to me, it is the Wild West that we're dealing with here. So it is unknown and things are changing. It seems like almost every week there's a new model or a new technique. I don't think I would have been able to do the work that I did in the second example even a year ago. To answer your question, the answer is I really don't know. It's an experimental process that's definitely going to involve a lot of human interaction to try to refine it. So that's how I see it, and I do think it's possible with the use of LLMs, but it will require a lot of tweaking from humans.
Yeah, I think the the human element is very important. So I think then the question, as I understood, how to bring that to a bigger, bring that together on a bigger scale. I think here, yeah, and it's a kind of an old question. I think it's really about bringing together or facilitating interdisciplinary work, leveraging kind of data models that are already there, like CDOC CRM, but then being able to tweak that to that they really speak across different disciplines. And I think here, yeah, we need to build kind of these structures that enable this kind of work.
Perfect, thank you. And got one question to Natasha, you probably can see them on the Q&A. What is the difference between feeding researcher notes to ChatGPT as opposed to feeding an entire document paper directly to ChatGPT by bypassing the notes?
So this was something I wanted to experiment with in this exact proof of concept study. And I mentioned that I used digitized notes, digitized files, as well as the notes, but getting those digitized files to a point where they're OCR'd enough that ChatGPT can understand them is a humongous task. A completely separate project that Nayomi and I are working on, we're dealing with basically newsletters, and we're trying to OCR them to feed them into a RAG pipeline. It's an enormous amount of work. And so, yeah, it would probably be great if we could give the whole document to ChatGPT, but we can't currently because the layout can be complicated and the scan can be not clear enough. Even the process of OCR is not there yet.
Perfect. Thank you very much. So thank you, Natasha, Marco, Nayomi, Congruence Engine and Sloane Lab, as well as the TaNC director to help us have this webinar. So we're gonna have to close it because we're running out of time. But keep in mind, we have a series of more webinars coming up. So follow us on Twitter, register on Eventbrite for our events. And again, thank you very much. Yeah, we have their contacts on Eventbrite if you want to contact them or follow their projects as well. Thank you very much and have a good afternoon.
Thank you very much.
Thank you.